this works the best if I can show you guys what's going on with the sun and planets. So I turn the camera around and we're going to see how this works. We're going to start by writing down these 3 questions, which hopefully we will be able to answer in the next couple days. All right. Question number 1, how long is a day? Question number 2, how long is a month? And question number 3, what is a leap year and why do we have them? You might think that you know the answers to these, but I can promise you, you don't have the full answer. All right. Go ahead and write these down in your science journal. We're going to start with the first one. How long is a day? A day is, most people would say 24 hours. They're half correct because there's 2 ways to measure a day. All right. There is a solar day. Then there's what's called a sidereal day. And a sidereal day, whenever you see that word, it means a full 360 because it is measuring from a distant star. So it's an object doing a full 360 degree rotation. Solar day, we'll get to that in just a second. But there are 2 different types of days. In your science journal, I would like you to make this little T-chart. Okay? Sidereal day on one side, solar day on the other. And then you guys need to have a definition, a length, as well as a sketch. Now go to this link, and I want you guys to fill in as much of this T-chart as you can on your own before I go over anything. A sidereal day, what is it? By definition, it just means a full 360 degree rotation. If you guys are a distant star, let's say you are a star that's 100 light years away, and you're looking at Earth, and you see this little dot on the surface of Earth, well, 360 degrees later, you're going to see that same little dot. If I'm standing on Earth and I'm looking at a star, 360 degrees later, I'm going to be looking at that exact same star. That's a sidereal day. It's one rotation of planet Earth. If you go out and ask people what a day is, that's usually what they're going to say. They're going to say, how do you measure a day? Before you get into how long it is, the time period, how do you measure it? They're going to say it's one complete rotation of planet Earth. So the definition of a sidereal day is a 360 degree rotation. Pretty simple, 360 degrees. A solar day is a little bit more, and here's why. A solar day, it's the rotation period that it takes to get from noon to noon, or from midnight to midnight, or from 2 in the afternoon to 2 in the afternoon. It's 24 hours. We just learned that if I see a star, 360 degrees later, I will see the same star. That's not 24 hours. The reason is that Earth is orbiting around the sun. The daily cycle, 24 hours, most people think is one rotation of the Earth. But 24 hours is not 360 degree rotation. It's a little tiny bit more. All right? The reason is that if we bring the sun into the equation, as the Earth is rotating, it is also revolving. It is also orbiting. It has moved its location in its orbit. So what happens is this. You have the sun, and it's directly over his little nose. And as the Earth is rotating, it's also orbiting. And this is very exaggerated so you can kind of get the picture. It's now done 360 degrees. How do I know? Well, because the same stars would be in the same spot. The problem is that his little nose is
the
not
only person in this conference.
The problem is that his little nose is not pointed back at the sun. So what would have to happen is he has to turn just a little bit more to get his nose pointed back at the sun. That's 24 hours. So we have a 360 degree rotation. That is about 23 hours and 56 minutes. And because the Earth has moved in its orbit, it has to turn 4 more minutes to get the sun back directly overhead. This 360 degree rotation, that's known as a sidereal day. 4 more minutes, 24 hours, that's a solar day to get the sun back where it started. You can see that in number 1, You have a place on Earth pointed directly at the sun. I'm going to pretend in this instance that you guys are the sun. Directly at the sun. And then the Earth is orbiting and rotating. And 2, the Earth has done a full 360-degree rotation. But it's not pointed back at the sun yet. The Earth has to go to number 3 4 more minutes more until it's rotated back and the sun is in the same spot in the sky. So this is a 360-degree rotation. It takes about 23 hours and 56 minutes. A full 24 hours is more than 360-degree rotation.
Let's begin with the most basic unit of time in this lesson, 1 day. What is a day to you? Likely you think of a day as something that's 24 hours long, the period of time between high noon today and high noon tomorrow, or the amount of time it takes the sun to appear on the meridian again. All are correct, refer to basically the same thing, and all use the sun as a reference point. Thus, a solar day is the time it takes for the Earth to rotate on its axis, so that the sun is in the same position in the sky as it was the day before, 24 hours. Your watch and modern societies run on solar time. The solar day is the basis for civil timekeeping. Contrast this with the sidereal day, the time it takes for Earth to rotate on its axis, so that distant stars appear in the same position in the sky as the day before, 23 hours, 56 minutes, and 4 seconds. Astronomers often like to use a sidereal day as opposed to a solar day because it tells them when a certain star will return to the meridian the next night, making it easy to spot. For us, however, it's important to note and explain the obvious. A sidereal day is shorter than a solar day. Why? This happens because the Earth orbits the sun as it turns on its own axis. Over the course of a day, the Earth will move about 1 degree on its year-long orbit around the sun. We get this by dividing 360 degrees in its orbit by about 365.25 days in a year. This means the sun appears to move on our sky 1 degree from west to east relative to the distant or quote fixed stars. Therefore, the Earth has to turn about 4 minutes more each day for 1 full solar day to occur. We get this number by dividing 360 degrees by 24 hours for 15 degrees in 1 hour, and thus about 4 minutes per degree.
What I would like you guys to do is compare and contrast the solar day and the sidereal day. What are at least 2 things that they have in common with each other? And at least 2 things that they have that are different from one another. Write that down in your science journal. Create a Venn diagram in your science journal. Why is there a difference? You have to know why there's a difference between a sidereal day and a solar day. If I was going to make this Venn diagram in my science journal, this is what I would write down. All right. Things that they have in common, they're both caused by the Earth rotating. They're both useful, and they're both measured by things in the sky. What do they have that's different? Well, one's 23 hours and 56 minutes. One's 4 minutes longer, 24 hours. One's a 360-degree turn, or rotation. One's a little bit more than that. And the 360-degree rotation is often used by astronomers to denote 1 day, whereas the 24 hours is used by everybody else.
What exactly is a day? You learned in school that a day is the time it takes for the Earth to rotate once on its axis. But with respect to what? In order to define something's motion, it always must be measured relative to something else. Let's say we measured the Earth's rotation with respect to the sun. So we start counting as soon as the sun is highest in the sky, and then stop counting when it reaches that point a second time. This 24-hour period is called a solar day, and it's what we base our clocks off of. But what if we measured the Earth's rotation with respect to some distant stars instead? Interestingly, this day, which we call a sidereal day, only takes 23 hours, 56 minutes, and 4 seconds. But why the difference? Well, for demonstration purposes, let's leave the Earth for a moment. Whoa, Okay, now we're here. There is a massive arrow sticking out of the Earth right now. How beautiful. For the Earth to rotate a full 360 degrees and end up with the arrow pointing back at those distant stars, it takes one sidereal day. But during that time, the Earth moved a little bit in its orbit around the Sun, so the arrow is no longer pointing in that direction. For that to happen, the Earth needs to rotate a little bit more, which takes about 4 minutes. So a solar day is about 4 minutes longer than a sidereal day, and consequently, stars rise 4 minutes earlier every night.